Hi guys, so today we are going to speak about non-exact differential equation, okay, for case 2. It is a case in which the differential equation that is not exact is presented in this form, in the form of f1 xy, okay, where the function multiplying y dx is in form of xy, okay, xy. And f1 xy y dx plus f2 xy x dy, okay, where m is equal to f1 xy y dx and n is equal to f2 xy x dy, okay. So as we know, whenever a function is non-exact, we can, okay, we can reduce to an exact form just by multiplying, okay, by multiplying the non-exact differential equation by the integrating factor. And when the function looks like this, is in form of this, is in this form, so the integrating factor will be what? Will be 1 upon mx minus ny. Okay, for homogeneous it should be plus, but for case 2, that is non-exact differential equation that looks like in this way, so we have to reduce this one to a exact differential equation by multiplying the integrating factor in form of 1 upon mx minus ny. Nice. It's okay. Then after multiplying this differential equation, okay, by this integrating factor, so it will be now a exact differential equation and can be solved by the exact differential equation method, okay. That is m1. This m1 is m multiplied by integrating factor. This n1 is n multiplied by integrating factor. That's why we put m1. Some people will write m dash or n dash. It's up on them, okay. Yeah. Now let us solve for this exercise and you can solve for the other ones. Nice. Okay. See, here we have this function, okay. So the first thing we have to do is to check whether this function is or not a exact differential equation. So just compare, okay, compare with this expression here, mxy dx. First thing is to compare, okay, mxy dy equal to 0. If you compare, this is equal to this and this is equal to this, okay. So what you mean, m is equal to x squared, okay, y squared plus 2 times y, okay, and n is equal to 2 minus x squared y squared and time x, okay. What's the next step? Find what is the derivative of m with respect to y and find what is the derivative of n with respect to x, okay. Here just find this time this and this time this. What you're going to have? Yeah, you're going to have 2x, okay, 2x minus x cubed and y squared, okay. This is then derivative with respect to x. Just find this derivative. This will be 2 minus 3x squared y squared. And here, if you found the derivative of this guy, okay, del y, it is x squared y squared, y cubed, sorry, and here this will be plus 2y, okay. This will be del m upon del y, it's del n upon del x, del m upon del y, it will be equal to, just apply derivative with respect to y, it will be what? Will be 3x squared and y squared plus 2. If you just see them and compare, you'll see that they are not equal. They cannot be equal, okay. So now we can say that del m, okay, as del m del y is different of del n del x, so it is non-exact, okay, differential equation, okay. this non-exact differential equation. So when this is not exact differential equation, we have to see now what is the form of this non-exact differential equation. Let us see, is this an homogeneous function? Okay, is this an homogeneous function? See, check here. This is the homogeneous function. No, it's not a homogeneous function, because here the degree is the degree of this expression here, of this polynomial. Yeah, the degree of this polynomial is 4, and the degree of this polynomial is 0 or 1. You see? 1, because when you multiply this will be 1, 2y. And here, if you multiply it, will be 5. So we cannot say that this guy is homogeneous. Okay, as long as all the terms have different degree. Okay, all the how can I say, all monomial here, all polynomial here has different degrees, so we cannot consider this as a homogeneous function. So now we have to see, is this function in the form of f of xy on y dx? Okay, we have to see, is in the form of this y, f of xy plus f of xy, okay, to x dy equal to 0. Is it in this form? Let us see. It is x squared y squared plus 2 y dx plus 2 minus xy squared and x dx equal to 0. So from what we can see is that this is true, because this function is a function of xy, and this one is a function of xy. And here we have y dx and y dx. So this is this y is this y, this y is this one. This is this function, this x is this x, and this y dy dx. So this is dy. So, yeah, this dy is dy. So it is fulfilled. Okay, so it means that this function is in the form of case 2. Okay, this is the function is in the form of case 2. Okay, case 2 type function. Okay, if this is in the form of case 2 type function, so it is non-homogeneous. It's not exact. What we have to do, we have to find what is if for case 2. If for case 2 is 1 upon mx minus ny. So then after finding this guy, just solve them. Okay, just solve for them. So okay, as this is non-homogeneous, this must be reduced to a homogeneous. As this is not exact, we must reduce to an exact differential equation by multiplying by this if. Why is this if 1 upon mx minus ny? Because it is in this form. Okay, yes. Now what you have to do, you know what is m. Okay, m is x squared y squared plus 2 times y. You know what is n. Just substitute. You are going to see this. This will be 1 upon, what is m? X squared y squared plus 2 times y. Now you have to multiply x. Then minus, put here your n. N is 2 minus x squared y squared times x, and here time y, just like this. Okay, so it will be there 1 upon, just multiply all this term, x and y will be xy. If you multiply this and this, you are going to have this one, x cubed y cubed plus 2xy minus, okay, this and go for them, 2xy, and here it will be plus x cubed and y cubed. Okay, now that you form this one, it will be 1. See, this and this will be cancelled out. It will be only 2x cubed and y cubed. This is your if. It means that this is the expression that you are going to use to multiply for this whole equation to make it a exact differential equation. Then apply the exact differential equation method to solve this. Okay, Let us now multiply. Okay, we will multiply if. Now you just multiply them. I will multiply this and this, so it will be 1 upon 2x cubed y cubed time what? Time x square y cubed. I just multiplied. Okay, I just multiplied with this y. You see this y? Multiply this and multiply here. Just multiply. This will be plus 2y. Okay, dx plus 1 upon 2x cubed y cubed multiplied by 2x minus, okay, x cubed y squared. Just multiplied also. Okay, x here and x there. It will be dy equal to 0. Is that okay? Now what is the next step here? It is just now reduced. The next step here is just simplification. Do some simplification here. As you can see here, you can simplify x cubed and x squared. It will remain x here down, and x cubed and y cubed will be simplified. So here you get only 1 upon 2x dx. Okay, here from here you get only 1 upon 2x dx, and here you get down also, let me write 1 upon, this will be 1 upon 2x plus, okay, this and this and this and this. Here you have just to simplify this y and this y and this 2 and this 2. It will be 1 upon x cubed. Okay, it will be 1 upon x cubed, just this and this, 1 upon x cubed and y squared, 1 upon x cubed and y squared dx. Okay, then just keep it up, plus, and this, do this simplification. 2 and 2 will going to be simplified, x and here would be x squared only and y cubed, so it will be 1 upon x squared y cubed minus, now see here, x cubed and x cubed will be cancelled out, and y cubed and y squared will be cancelled out. This one, it will remain y, so it will be 1 upon 2y dy equal to 0. Okay, so this simplification there will end in this way. Okay, will end in this way. So after doing this simplification, now we know this is m1. Okay, this is m1 and this is n1. So m1 will be 1 upon 2x plus 1 upon x cubed y squared, and n1 will be 1 upon x squared y cubed minus 1 upon 2y. So if you derive this with respect to y and derive this with respect to x, this will be the same, the very same expressions. Okay, so del m1 del y. Okay, you can skip this step if you feel like. Okay, if you feel like no more time, you can just skip the step. So if you derive this guy with respect to x, this will be 0. With respect to y, will be 0, and this y will be constant. Okay, so you have minus 1, and this guy, it will be minus 1. This will be 0, and here it will be yx cubed as constant, and here will be minus, okay, 2y, and here y to the power 4. Okay, here the same, this will be 0. Okay, yeah, this will be 0 if you derive, and what you're going to have, this 1 upon y cubed will be constant, and this one will be 2x negative with x cubed, x to the power 4. Just find the common denominator. Okay, just find the common denominator here. Now if you find this one, the common denominator here, this and this will be cancelled out. You're going to have minus 2 upon x cubed y cubed. Okay, and here del n1 del x is equal to the same, just do this one will be minus 2 upon y cubed and x cubed. Okay, so they will be the same, so you can skip this step. Okay, just write directly after multiplying this. This is okay, this is you can just write directly del m1 del y is equal to del n 1 del x. Okay, now it is exact. Okay, now it is exact. If this is exact, now what you're going to do, you have just to multiply this is you have just to apply integration for this guy and integration for this guy. Okay, just like this. So the next step is integrating both sides. What you're going to have 1 upon 2x plus 1 upon x cubed y squared, and here dx plus integration of 1 upon x squared y cubed minus 1 upon 2y, okay, and here dy equal to c. Just integrate them. So there are some conditions. Y must be constant for this, okay, and for this one exclude all terms in x. Okay, just exclude all terms in x. So what you're going to see here, I have to exclude this term because this one has contain x out, and here y is constant. It means that this guy can be just solved this one. If you solve for this one, it will be integration of 1 by 2, okay, dx upon x, okay, plus 1 by y square. Y square is constant, so it can be out. Integration of x minus 3 dx. Okay, we know that y is constant here, y is constant here. Okay, so this will be minus, this guy will be minus 1 upon 2 integration of dy upon y. This is equal to c. So what does it mean, or what will it be? That's the point. Just find this integration and you are done. So it will be 1 by 2 ln of x plus 1y square, and this integration is x to the power minus 3 plus 1 upon minus 3 plus 1 minus 1 by 2 ln of y is equal to c. Yeah, and that will be 1 by 2 ln of x upon y, okay, plus 1 by y square, and here what you're going to see, this is minus 2 down, so it will be minus here, this will be minus 2, okay, and here 1 upon x square equal to c. Okay, go to c, just like that, and you are done. Okay, you are done. Thank you. You can solve for more exercise so that you can have more ideas and more way to solve, but the concept is this. Okay, now just remembering again. So first, what you have to do, the first step is, after seeing this is a differential equation, so check whether this differential equation is exact or not. We checked and we saw that this differential equation is not exact. If it is not exact, what should you have to do? You have to compare the general equation, the given differential equation, whether this function, this general differential equation is homogeneous or not. This is not homogeneous. Then we compare it with the second case, okay, and that is when it is presented in this form, f of x y dx, and you can see this is a function of f of x y, here y dx. Oh, f of x y, function of f of x y is here, this is x dy. So this is in the second form, so it is a second case type of non-exact differential equation. So for this second case, okay, the integrating factor, the number, the expression that you are going to multiply by the whole non-exact differential equation to make it reducible to reduce it to differential or to exact differential equation is if equal to 1 upon mx minus ny, and just do this one. After finding them, then multiply, okay, multiply all the terms of this exact differential equation by this integrating factor. After multiplied, so you are going to have an expression like this. If you multiply, then it's fine. Now what's the next step? Now that you multiplied, it is exact. okay, it can be reduced to an exact. Okay, yeah. Then after you see that this is an exact, apply exact method for differential equations. Okay, then you just apply, then you just exclude, and then you just solve this one. Okay, hope you can understand, and thank you very much. You can do the same for this exercise here. You can have this one. This is for you to do. Okay, you just do it home. And this one, you can see this is in the form of xy. This is a function of xy, and this is y dx. So we can say that this is the second case that we can apply. So in this case, to reduce it to exact differential equation, you have to apply, you have to multiply the integrating factor of this case, that is 1 upon mx minus ny. Okay, hope you can enjoy this. Try to solve this one, this 1 and 2, okay, and this exercise, and it will be fine for you. Thank you. Okay, it's not about being too much intelligent. It's all about being just calculist and know what you want or how you want to get your point. Thank you. See you for the next step, that is, or for the next video, that is case 3 that we are going to study next. Thank you.